So the last thing we're going to talk about in 2.3 is something called the intermediate value theorem. And all that says is this: if f is continuous on a closed interval from a to b, then f is going to take on every value between f of a and f of b. So suppose that k is any number between f of a and f of b. Then there is going to be at least one number c in a to b such that f of c is equal to k. And all that means is that c is your x and k is your y. Alright. So, intermediate value theorem tells you at least one c exists, but it does not give you a method for finding c. This theorem is just simply what we call an existence theorem, and that's it. It's not going to help us tell one c, but it's going to tell, hey, it exists, cool. So it says in the intermediate value theorem, what are the necessary requirements? Well, in order to apply this theorem, I've got some graph that, let's say, here's one of my endpoints on, let's call that A, and then let's call this B. And I know that I have to have a y value that exists everywhere in between. So I could have a graph that looks something like that, but there's going to be one continuous function, and it's going to have a y value that exists everywhere from a to b. Alright, that's all that's required. F is continuous. If it's continuous on. It's a little bit shorter. Alright, k is on which axis? Well, k is just simply your y value. So it's going to be your y-axis. And then c is on which axis? I kind of gave that away. That is function notation. So normally it's f of x. And the x got replaced with c. So c is on your x-axis. Alright, and that's it. That's all for that. Alright, so example 8 says consider the following function below. It says is f continuous on a to b? Well, yeah, I don't see any jumps, I don't see any holes, I don't see any vertical asymptotes. Is k between f of a and f of b? Well, here's f of a, here's f of b. K is literally between the two, so yes it is. Alright, and then in this example, is c basically between a and b? Yeah, it is. We can pick some point c, we don't really care what it is. Then there are going to be oops, did not mean to do that. So if this is k, I'm gonna have this point here, this point here, and this point here. Those are just my c's. So I can call that c1, c2, c3. If I put another one, it's a little bit explosive. Alright, so there's only 3 c's, such that f of c is equal to k. And I just labeled those. Oops. So that's already taken care of. Alright, so the last thing that we gotta do is example 9. We gotta verify that the intermediate value theorem applies on the interval from 5/2 to 4, and explain why that intermediate value theorem guarantees an x value where of c, where f of c is equal to 6. Alright, so the first thing I gotta do is see if this function is even continuous on that interval. So what I'm gonna do is I'm gonna find out where is this function discontinuous. Well, I see a fraction with an x in the denominator. So fractions with an x in the denominator tells me, it might equal 0 at some point. And so I gotta figure out where that point would be. So I know that x minus 1 could be equal to 0, so x has to equal 1 in order for that to be 0, which is a bad day. That's the number I want to avoid, so I do not want x to equal 1. Alright, because it's in a denominator, there would actually be a vertical asymptote there. That's just a fraction in general. Alright, so then I go and I'm like, is 1 in my interval? Well, 5/2, that's 2.5 to 4. 1 is nowhere in that interval. So, since it's not in that interval, yes, it's continuous on this interval. Alright, so how do we find this piece of it? Well, now I'm going to go in and I'm going to see, hey, where do I start y value wise and where do I end y value wise? The easiest way to figure that out is literally go in, plug in 5/2. So I'm going to have f of 5/2 is equal to 5/2 squared plus 5/2 all over 5/2 minus 1. Alright. So that should give me what? 25 over 4 plus 10 over 4 over 3/2. And I'm just going to go ahead and change that to 6/4. Yeah, alright. So then I would have 35 over 4 times 4 over 6. So then the 4's cancel out, leaving with just 35 over 6. Alright. And then I'm going to go in and plug in 4. Alright. So then I've got 4 squared plus 4 all over 4 minus 1, which should be equal to 16 plus 4 all over 3, which should equal 20 over 3. Alright. So all I've done is replace my fractions with decimals this time around, just because it's going to be easier to see if that's 6 or not. So I see that my y values start at 5.83333333, etc. And then my next values are at 6 2/3 on my next endpoint. So since my interval goes from 5.833 all the way to 6.666. Should be on my y-axis though. Sorry. Alright. 6 is going to be somewhere in here. So that means that guarantees that f of c is equal to 6 at some point. So it's calculus, we got to write a little sentence. So since f is continuous on 5/2 to 4 and f of 5 over 2 is equal to 5 and 5/6 basically, and f, what the f, oh, f of, oops, I'm just going to restart down there, and f of 4 is equal to 6.666 repeating. The IVT, which is the intermediate value theorem, guarantees, UA, GAU, GUA. I hope that's spelled right. A value of C between 5 halves and 4, where f of C is equal to 6. Alright, that's it. See you tomorrow.